The law of sines says that in any triangle, the lengths of the sides are proportional to the sines of the corresponding opposite angles. So in a triangle ABC, we have the formula sine A over A equals sine B over B equals sine C over C. This formula is the law of sines. In the law of sines, the capital letters A, B, and C are the interior angle measurements. In the law of sines, the lowercase a, b, and c are always the sides opposite of the angles, like so. In general, a triangle is determined by 3 of its 6 parts, angles and sides, as long as at least one of these parts is a side. Knowing this, we have 2 cases for the law of sines. You can have one side and 2 angles, abbreviated as SAA or ASA, side angle angle or angle side angle. Or you can have 2 sides and the angle opposite one of those sides, abbreviated as SSA or side side angle. These are the only 2 cases for the use for the law of sines. Now you gotta be careful. When given triangular parts SAA or ASA, it always guarantees a single unique triangle. However, SSA is different, and it leaves the triangle unclear, or what they would call ambiguous. And this is the tough part. The ambiguous case, SSA, occurs when we are given 2 sides and the angle opposite one of these given sides. So the hard part is this. When you have the ambiguous case, you can actually have 3 different outcomes. You could have an outcome that's 0 triangles, 1 triangle, or 2 triangles. And the way you can tell is you can use this table here to see which one you would have for 0 triangles, 1 triangle, or 2 triangles. And I'll go over how to figure out which one of these you'll get in some videos in the future. But one thing you do need to know is that when you're relying on A being less than B, you need to use the law of sines to determine sine B. If sine B is greater than 1, that means you have no triangles. And if sine B is less than 1, you have 2 triangles.